All right, here we go. We have a warm-up. Which ordered pair is a solution to the system of equations y equals x and y is equal to x squared minus 2? Go ahead and put me on pause, try the problem, and then start it back up and let's see how you did. You guys could use a process of elimination and do a guess and check. So if you were to actually start with maybe choice 3, the 0, 0 might be the easiest one to check. You would have 0, does 0 equal 0? Substituting the x and the y back into both equations, this one over here would be is equal to 0 squared minus 2. 0 is equal to 0 squared is 0, and 0 minus 2 is equal to negative 2, which is not true. So 0, 0 works for this equation, but not this equation, so I'm going to cross that off. I'm going to go ahead and try the 2, 2. This is not the only way of doing it, guys. We could actually do substitution or elimination. I'm not sure which way you did it. So let's go ahead and put 2, 2 into the first equation, which would be 2 equals 2, which that's true. And now let's put it into the second equation, which would be 2 is equal to 2 squared minus 2. And that gives me 4 minus 2, and 2 equals 2, which that checks. So that would actually be the right answer. Okay, let's go ahead and get going on to section 6-3, which is solving systems using elimination. You have been taught how to solve a system of equations graphically. You've been taught how to do substitution, and now we're going to go ahead and do elimination. Elimination is an algebraic method. You want to make sure that you order the two equations in the same order. It doesn't matter what order. You could put them in y equals mx plus b form. You could put them in standard form. You wouldn't want to do point slope form because of the parentheses, but actually could be any order outside of those three orders, and just make sure that both equations are in the same order so that when in step number 2 you line them up under each other, the x's are above the x's, the y's are above the y's, and the equal signs are above the equal signs. Step 3, you're going to get one of the variables' coefficients to be the same number in opposite signs. So this part is important. Same number and opposite signs, and I'll explain that more when we get to an actual problem. Then you're going to add the like terms, and then you're going to notice that elimination is going to end up happening on one of those variables. So let's go ahead and look at an example. So in this example, you'll notice that both equations they gave us, we have to use elimination, they gave us are in the same order. They're both in standard form, which is great. So let's go ahead and put one under the other. So if I take 2x plus 5y equals 17, and then take the second one and put it right under it, because they've already been given to us in the same order, that means that when I draw a line across here, the x's line up, the y's line up, and the equal signs line up. You want it to do that. Like I said, it can be in any order you want, just make sure they're both in the same order. Then the next trick is to look at the coefficients in front of the x's. If you look at the coefficients 2 and 6, if I were to add these two terms together because they're like terms, you would get 2x plus 6x, which would be 8x. And we want to look for where they're going to eliminate. In order for them to eliminate, we need the coefficients to be opposite signs. One has to be a negative, one has to be a positive, and then they have to have the same coefficient. If you look at the y terms, the coefficients are 5 and negative 5. They're opposite signs and they're both 5s. So this one is an easier system of equations by elimination because the 5y and the negative 5 are actually going to eliminate when I add these two equations together. So let's go ahead and add them. 2x plus 6x is equal to 8x. 5y plus a negative 5y cancels, that's why they call it elimination. And 17 plus a negative 9 is 8. Okay, divide both sides by 8, and we get x is equal to 1. So now, once you've figured out one of the variables, doesn't matter which one you figure out first, you're going to substitute that answer back into one of the original equations. I'll just go ahead and do it on the second one. so we can find y. So it's going to be 6 times x, which we found to be 1, minus 5 times y is equal to negative 9. 6 times 1 is 6, minus 5y is equal to negative 9. Subtract 6 from both sides. You can stay with me or stay ahead of me, that's even better. Negative 9 minus 6 is negative 15. Divide both sides by negative 5. And we end up with y is equal to 3. Notice that the answer comes out to nice even numbers of 1, 3. The point 1 comma 3. So if I was to actually graph these two, which I don't have to and I'm not going to, we would notice that the two lines would actually intersect at the point 1 comma 3, which would not be hard to figure out graphically. But if the answers ever come out to actual decimals or fractions, then graphically would have been a bad choice. Let's go ahead and do our checks. Check number 1, I'm going to squeeze them right in here. I'm going to take the first equation and I'm going to substitute in my x, which I got 1, plus 5 times my y, which I got 3, and I'm going to see if this works out to 17. 2 times 1 is 2, 5 times 3 is 15, is equal to 17, and 17 equals 17, so that one checks. Please understand that if one of these equations checks and the other doesn't, then we actually have a mistake somewhere. So it's important to know that you have to do both checks because we have two equations that have to work out. I'm substituting it into the second equation, which is the one up here. And I'm getting 6 minus 15 equals negative 9. 6 minus 15 is negative 9. And it checks. So now I can go ahead and circle my answers because I have confirmed that those two are correct. All right, let's look at a word problem that deals with a system of equations. It says the theater club sells a total of 101 tickets. 101 tickets altogether. They made $164. A student ticket costs $1. An adult ticket costs $2.50. How many student tickets were sold? All right, well, we're looking for two different things. Actually, we're looking for the number of student tickets, but we're going to go ahead and find both. So we're going to let x equal the number of student tickets. And we're going to let y equal the number of adult tickets. Because we have two different variables, you have to make sure that you understand that you have to have two different equations. For every different variable you have, that's going to require a different equation in order to solve the problem. So the first thing we read in the beginning, there were 101 tickets sold. So I have 100, I have X student tickets plus all my adult tickets. If you add that up, that comes out to 101 tickets sold altogether. My second equation would be the money part of it. It's $1 times the student tickets plus $2.50, which I can write as 2.5, times all the adult tickets, comes out to $164 total. Now, if you notice when I wrote these two equations, it turns out that both of them are in standard form. So therefore, I can actually, because they're already in the same order, I can use elimination process to solve this. I actually could do substitution as well. It would probably be just as easy. The only problem is when you do substitution, you would want to solve for either the x or the y over here or possibly the x over here. Graphically, I want to avoid for two reasons. One, because it's a decimal involved and there's a pretty large number we're dealing with. We're going to go ahead and do elimination for the sake of the fact that we're learning it right now, and we're going to practice. So you take the two equations and you line them one above the other. Now, when you do that, they line up. So the x's are above the x's, the y's are above the y's. However, if you look at the coefficients, the coefficient on the x's are both 1s, which we like because we want these numbers to be the same. The problem is one needs to be a negative and one needs to be a positive. It doesn't matter which. But in order for them to cancel or eliminate, we have to have opposite signs. So I actually can change this. I can make one of these a negative, and I'll make the top one a negative by multiplying by a -1. But understand that means you've got to do it to the whole equation. So it's negative 1 times x is negative x, negative 1 times y is negative y, and negative 1 times 101 is negative 101. Don't forget, when you multiply through on an equation, you have to do it through every term, even across that equal sign. That's usually one of the common mistakes. The second equation, I don't have to change because I like the fact that it is now opposite signs and the same coefficient. So I'm just going to bring it over. And now when they line up, you will notice that if I add these two together, negative x plus positive x cancels, elimination. We really have a negative 1y plus a 2.5, whoops, I forgot my y in here. Let me put that in. So now I have negative 1y plus 2.5 is 1.5y is equal to 164 plus a negative 101, which is equal to 63. And then you divide both sides by 1.5. And we're going to end up with y is equal to 42. So therefore, going back to our let statement, which you will have to have because this is a word problem, the number of adult tickets they sold were 42 adult tickets. Now, in order to find the number of student tickets, which is x, we're going to go ahead and substitute the 42 back into one of these equations. I'm going to use the first one because it's avoiding my decimal. I'm going to use the x plus my y, which is 42, is equal to 101. Subtract 42 from both sides. So I have 101, and I'm going to subtract 42. And I'm going to get x is equal to 59. Therefore, that means that you have sold, answering the question, how many student tickets were sold? That would be 59 student tickets. Don't forget though, guys, even with word problems, you're going to have to do your checks. So, by doing my checks, see if I can squeeze it in over here. My first check is going to be 42 plus my 59. Does that equal 101? Well, I get 90 plus another 11, which is 101, is equal to 101. So that one checks. The second one is my x, which is 59, plus 2.5 times my 42. Does that equal 164? It's 59 plus 2.5 times 42 equals 105. If you take 105 and you add that to 59, it will give you 164. So it checks, and therefore my circled answer over here is correct. All right, go ahead and try this one on your own. Let's go ahead and line them up. We're going to get negative 2x plus 15y equals negative 32. 7x minus 5y equals 17. Now, some of you guys are going to eliminate the x's and some are going to eliminate the y's. It doesn't matter what you do, but you got to find both anyway. If I want to eliminate the x's, one's a negative, one's a positive, that works, but I would want to both get them to 14. So I'd have to multiply all of this by 7 and all of this by 2. Or, I kind of like the idea down here. If I eliminate my y's, this is a positive, this is a negative, and all I need to do, if this is a 15, I need to get this guy to a negative 15. So if I multiply the second equation all the way through by a 3, 3 times the negative 5 would give me my negative 15. And that would help me eliminate my y's. So it's kind of personal preference. Sometimes it's easier to eliminate the x's and the y's. 3 times 7x is 21x minus 15y equals 17 times 3 is 51. I'm probably going to run out of time here, but those guys eliminate. You're going to end up with 19x is equal to 51 minus 32 is 19. Divide, you're going to get 1 for x.